Hello friends, continuing with the chapter of communication systems, today we come to its third part, that is communication systems part 3. Here first we will learn about some definitions, then classification of communication systems and communication channels. So first we take up some definitions. Now first is signal. What is signal? Now this is the signal which is having a graph between amplitude versus time. Now let us define. Signal is a single valued function of time that contains information and possesses unique value at every instant of time. I repeat, the signal is a single valued function of time that contains information and possesses unique value at every instant of time. Now second, message signal. Let us define message signal. A time varying electrical signal generated from original signal using an appropriated transducer. I repeat, a time varying electrical signal generated from original signal using an appropriate transducer is defined as message signal. Now here we have come across a term transducer. Now let us define transducer. Transducer is a device used to transform energy from one form to the other. I repeat, a transducer is a device used to transform energy from one form to the other. For example, a microphone. Microphone converts audio energy into electrical energy. Second is earphone or loudspeaker. Earphone or loudspeaker converts electrical energy into audio energy. Third, light emitting or laser diode. Light emitting diode or laser diode converts electrical energy into light energy. Number 4, photodiode. Photodiode converts light energy into electrical energy. Number 5th, solar cell. Solar cell converts light energy into electrical energy. So all these are transducers. Also others are just like motor. Motor converts electrical energy into mechanical energy. And generator. Generator converts mechanical energy into electrical energy. So all these are transducers. So transducer is a device used to transform energy from one form to the other. I repeat, transducer is a device used to transform energy from one form to the other. Fourth, bandwidth. Let us define bandwidth of a signal. Range of frequencies of the signal over which it is spread and is corresponding to RMS points of the signal is known as bandwidth of the signal. I repeat, range of frequencies of the signal over which it is spread and is corresponding to RMS points of the signal is known as bandwidth of the signal. And look at this diagram. This diagram represents graph between amplitude of the signal versus frequency of the signal. The amplitude of the signal varies according to frequency. Okay, so these are two RMS points, and F1 is frequency corresponding to lower RMS points, F2 is the frequency corresponding to upper RMS points, and F0 is the central frequency where amplitude is maximum. Now mathematical expression. Now mathematically bandwidth is expressed as, say, BW. It is equal to F2 minus F1, or it is equal to 2 into F0 minus F1, or it is equal to 2 into F2 minus F0, because F0 is central frequency. Now fifth, baseband. Let us define baseband. The band of frequencies represented in original signal as delivered by the source of information. I repeat, the band of frequencies represented in original signal as delivered by the source of information is defined as baseband. Now sixth, characteristics of a signal. Two main characteristics of a signal are amplitude and frequency. I repeat, two main characteristics of a signal are number 1 amplitude, number 2 frequency. Okay. Now seventh, types of signals. First, analog signal. Let us define analog signal. A time varying voltage or current having continuous values is defined as analog signal, as shown in diagram. So this is analog signal. Second, digital signal. A time varying voltage or current having two discrete values, either 0 or 1. I repeat, a time varying voltage or current having two discrete values, either 0 or 1, is defined as digital signal. So this is a digital signal where we have two values, 0 and 1. Another term we have to understand is communication. What is communication? The faithful transmission and reception of information or message between 2 points is known as communication. I repeat, the faithful transmission and reception of information or message between 2 points is known as communication. Means, if a message is generated, it is transmitted to a receiver and receiver understands it properly, then we say communication has taken place. And then receiver sends a message, it is received and understood by the transmitter side receiver, then we say communication is established both ways. Means, when a transmitter sends a signal to the receiver, it is received in its original form and is understood properly, then we say it is simplex communication. And when receiver side transmitter generates a signal and is sent to the transmitter side receiver, it receives that signal and understands it, then we say it is duplex communication system. Okay. Simplex is one way, duplex is both ways. Like in mobile communication, we have both ways communication, so it is duplex communication. Now, communication system. Let us define communication system. The setup which transfer and accepts information implicitly from one point to the other is known as communication system. I repeat, the setup which transfer and accepts information implicitly from one point to the other is known as communication system. Now, basic units of any communication system. Following is the block diagram of any type of communication system showing basic units. The basic units are: number 1, generation of information; number 2, transmitter, which is denoted by generally TX; number 3, transmission channel; number 4, receiver, which is denoted by RX; and number 5, user of information. and number 6 the noise which is generated on the way and is mixed with the signal. I repeat, number 1 generation of information, number 2 transmitter, number 3 transmission channel, number 4 receiver, number 5 user of information, and at the 6th we have noise that is mixed up on the way from transmitter to receiver with the signal. Okay. Now classification of communication systems. Various types of communication systems can be classified as follows. First, according to nature of information. Second, according to mode of transmission. Third, according to type of communication channel used. Fourth, according to type of modulation. So we take up one by one. First, we take up according to nature of information. We have speech communication, we have motion picture communication, and we have fax, that is facsimile transmission, and data transmission. I repeat, according to nature of information, we have communication system where we have speech transmission directly, or motion picture, that is television, fax, that is facsimile transmission, and fourth is data transmission. Now according to mode of transmission, we have two types of communication system. One is analog communication system, second is digital communication system, that is X is a symbol for transmission, or we say analog transmission, or we say digital transmission. So these are two communication systems on the basis of mode of transmission. Either we transmit in analog mode or we transmit in digital mode. Now third, according to type of communication channel. We send signal through guided medium channel, for example line communication, or we send signal through unguided medium channel, that is wireless communication system, where we have surface waves, sky waves, and space waves. I repeat, we send signal through guided medium channel or unguided medium channel. In guided medium channel, we have line communication system where we have different types of lines, two-wire open line or coaxial cable, or then optical fiber. In unguided medium channel, we have surface waves, sky waves, and space waves. Okay. Now according to type of modulation. In analog communication, we have amplitude modulation AM, frequency modulation FM, and phase modulation PM. In digital communication, we have pulse modulation, which is of various types: pulse amplitude modulation, pulse width modulation, pulse duration modulation, or pulse code modulation. So this way we classify communication system in 4 categories according to nature of information, according to mode of transmission, according to type of communication channel used, and according to type of modulation used. Okay. Now we have come across a term as communication channel. Now let us define communication channel. The physical medium through which signals may propagate to establish a communication system between a transmitting and receiving stations is known as communication channel. I repeat, the physical medium through which signals may propagate to establish a communication system between a transmitting and receiving station is known as a communication channel. Now types of communication channels. There are two types of communication channel we generally come across. First is unguided medium channel, second is guided medium channel. Now we take up one by one. First we take up unguided medium channel. Let us define unguided medium channel. The channel in which signals are not guided by the medium for its propagation but are guided by the antenna to propagate in a particular direction. I repeat, the channel in which signals are not guided by the medium for its propagation but are guided by the antenna to propagate in a particular direction is defined as unguided medium channel. Now, these antennas are either omnidirectional or bidirectional or unidirectional. Look at these diagrams. This is omnidirectional antenna, this is bidirectional antenna, this is unidirectional antenna. And for examples, unguided medium channels are surface waves, sky waves and space waves. These are radiated through these antennas and propagate to the receiving stations. Okay. So, we call them as unguided medium channels. Now, characteristics of unguided medium channels. The characteristics of unguided medium channels are reflected in this table. Now, we take up one by one. First, type of channel. First, surface waves is one kind of unguided medium channel. Sky waves are another kind of unguided medium channel, and space waves are third type of unguided medium channel. Now, second point we take up is frequency range. The frequency range of surface wave is 500 kilohertz to 1500 kilohertz, and for sky waves is 3 megahertz to 30 megahertz, and for space waves frequency range is 30 megahertz to 30 gigahertz. Number 3, wavelength range. The wavelength range we can calculate using the formula C is equal to nu lambda, and lambda is equal to C by nu. Nu is given to you and C is 3 into 10 to the power 8 meter per second. So, we can calculate wavelength range, upper limit as well as lower limit. Now, wavelength range of surface waves is 600 meter to 200 meter, and for sky wave is 100 meter to 10 meter, and for space waves it is 10 meter to 10 raised to power minus 3 meter. Now, fourth, type of modulation. Now, surface waves use amplitude modulation, sky waves also use amplitude modulation, and space waves use frequency modulation. Now, fifth, bandwidth of the channel. Bandwidth we can calculate upper limit of frequency range minus lower limit of frequency range. So, for surface waves we have bandwidth as 1000 kilohertz, and for sky waves we have bandwidth of 27 megahertz, and for space waves we have bandwidth of 29,970 megahertz. Now, sixth, channel spacing. Channel spacing for surface waves is 10 kilohertz for sound waves, and for sky waves again it is 10 kilohertz, and for space waves it is 40 kilohertz. Now, seventh, number of channels. Number of channels can be calculated as bandwidth divided by channel spacing. So, we can calculate for surface waves number of channels comes out to be 100, and for sky waves it comes out to be 2700, and for space waves it comes out to be 7.492 into 10 raised to power 6. So, these are number of channels. Eighth, range of communication. Range of communication for surface waves is 30 to 120 kilometer, and for sky waves it is thousands of kilometers, and for space waves it is depends upon line of sight, mode and power of transmission. Ninth, uses. Surface waves are used for local broadcast or commercial service. Sky waves are used for long distance broadcast, and space waves are used for FM broadcast, television, mobile and radar and satellite communications as well. Okay. So this is how we tabulate the characteristics of unguided medium channels, that is surface waves, sky waves and space waves. Now second, guided medium channels. The communication channel in which signal is guided by the medium to propagate in a particular direction is known as guided medium channel. I repeat, the communication channel in which signal is guided by the medium to propagate in a particular direction is known as guided medium channel. For example, line communication is a guided medium channel. For example, line communication includes guided medium channel. Guided medium channels in line communication are normally number 1, two-wire open line communication, number 2, twisted pair of line communication, number 3, coaxial cable communication, number 4, optical fiber communication. Okay. So 4 different guided medium channels we use in line communication. Now assignment 15 continues. Question number 15. What points are to be kept in mind while selecting a proper communication channel? Here is the answer for you, but you don't look at the answer, you write from your own learnings. Okay. Thank you so much. Next time we'll proceed to 4th part of communication system, that is modulation. Till then, goodbye and good luck to you.